Hi everyone. Let's get started. So first of all, before we get started on the content, I just want to take an opportunity to thank everyone joining us on this webinar. Really appreciate you guys taking time to talk about this. We're going to touch base mainly on how to eliminate unplanned downtime with remote condition monitoring. So just a quick introduction on what we're going to talk about, and then we can start getting into the actual content. So this webinar is going to show you how condition monitoring has helped prevent unplanned downtime and to get you to a full closed loop system that can help you both economically and to get a full-fledged idea of how your system is working in terms of equipment management. So before we get into the content, I wanted to just introduce myself. My name is Naveen George. I'm the product manager for the iAlert product line. Based out of Rochester, New York, worked in R&D for 6 years, focusing on the industry of the Internet of Things realm, and now leading and maintaining multiple products in the industrial Internet of Things space. I would like to introduce Akshay Sharma, and he'll give a brief description about himself.
Good afternoon. My name is Akshay Sharma. I'm the Global Monitoring and Controls Manager here at our ITT. A little bit of background about me. I've got an electrical engineering degree from Georgia Tech. And throughout my career, I've held a variety of roles in operations, engineering, R&D, field service, as well as sales support. I've worked on products primarily focused on instrumentation, controls, and wireless communication, with over a decade of experience specifically in the pump and mechanical seal industry. And our last speaker is David Rail, who will introduce himself as well.
Good afternoon, everyone. My name is David Rail. I'm the Senior Applications Engineer for monitoring products at ITT. Got about 30 years of experience with vibration and acoustics, and most recently with the iAlert at ITT.
Thanks, guys. I really appreciate you introducing yourself. Now, let's start talking about downtime, and let's talk about the effects of downtime and also how we can monitor it. So the biggest first talking point that we're going to talk about is the cost of downtime, kind of defining what it is and kind of giving some light on, because everyone here probably is aware of downtime, is understanding what it is, but let's put some actual numbers to it and see how it affects in different parts of the industry. So the first biggest thing is that 82% of all companies have experienced some sort of unplanned downtime. So the biggest thing is, what is unplanned downtime? Unplanned downtime is the biggest result of a failure that is not really planned for and is kind of sprung upon and can cause the most amount of negative effect in terms of the cost and also from a production standpoint. The main categories of unplanned downtime would be at least it would be broken down into if you process changeover, lack of operator, or unplanned machine maintenance. The unplanned machine maintenance piece is what we're going to kind of highlight at this point so that we can understand how covering the most amount of your equipment out in your field will help you to reduce that unplanned downtime. Everyone's talked about it, but what does it really mean in terms of actual costs, right? So, and usually, according to a lot of research that's done around industries, the length of downtime that happens per year or per event is 4 hours, is the average length of downtime, and usually costs some companies up to $260,000 per hour. Per hour is the average cost of downtime. And if you take that into consideration of the amount of events that happens and the cost per downtime, it can cost you anywhere over $1 million in lost revenue per unplanned event. So that itself just gives you a number that is not part of the budget, is not part of anyone's actual thought process when it comes to investment. It's just that this happens and how do we reduce it? So now knowing all these numbers, a lot of industries out there, what they've done is made zero unplanned downtime one of the highest priorities and make sure that they put that in the budget to figure out how we can monitor every equipment and figure out what is the best way to approach that zero unplanned downtime. So the biggest things is, first of all, figuring out what is the cost, what cost unplanned downtime, or how do we cover most equipment and figure out how can we even get to a point where we can predict the unplanned downtime. So 45% of all companies report hardware failure or malfunction played a role. So anything that like different types of malfunctions would be if you have process upsets, if you have misalignment or imbalance or any stuff like that that happens to your equipment, you would like to know about it, and not knowing about it is one of the biggest reasons why unplanned downtime occurs. So from knowing about that is also that we need to not just monitor the equipment that we have on hand, but also kind of have an idea when no one's around. So a lot of people are around equipment on the first and second shift, but if I'm not sure what's happening on the third shift, which according to the statistic is 70% of all downtime events occurs on second and third shift. So that itself tells me that I need to now monitor just not while people are working or in the first and second shift, but I need to have something that I can remote access or have a real-time analysis of what's happening in my field. And that's the biggest thing, right? That's one thing that a lot of people right now do is having preventive maintenance routes, have different processes already in place to kind of do a check when everybody's there. But what if no one's there? What if there's something goes bump in the night? How do I get a notification on that? So that is another place that people are improving on or are investing a lot more technologies to get to a point where you cover a lot more of your equipment. For obviously now, since the technology is getting better, you can afford that to cover more, not just critical equipment, but also non-critical equipment. And that can be seen for different, like the push towards digital. So that's the biggest thing from our standpoint is how can we find all the information that we need to do it in terms of just having it on a easy to view desktop, or find a way to have it on real time, but without much of red tape of collecting data from each point, having it remotely accessible. So a lot of investment is pushing towards that. A lot of our industry counterparts are investing in machine learning, mobility tools, IoT platforms, artificial intelligence. And the biggest thing you can see from this particular graph is just not what the investment has been done so far, is what is planned to do investment in the future. So this whole Internet of Things or industrial Internet of Things platform is just a start right now. It's growing as we speak, and the biggest thing is now get to a point where you can get more for the amount of money you invest in, and that's been seen also from how people are covering all of their plans with different types of sensors, different types of remote monitoring equipment, and and that's what we want to get it to all our industry counterparts. So one thing that we want to talk about is the history of the condition monitoring systems, which I'll let Akshay Sharma talk about.
Thank you, Naveen. So condition monitoring has evolved quite a lot over the past few decades. Starting off, we'll go back a little bit, back to the 80s, where condition monitoring was mostly a manual affair, tracking primarily lagging indicators. So that means looking at parameters when the failure has already taken place. It's also a very labor-intensive process to both collect and analyze the data with bulky and expensive equipment, some of which was limited to lab use only. Moving on to the 90s, with the advances that we saw in electronics and sensor technologies, we started to see more portable equipment and new data points being measured. So this progression continued into the early 2000s with wireless protocols beginning to emerge. And at this point, we were getting a lot more data, but it still required a lot of time and expertise to translate that data into information. So as we move forward into the 2010s, wireless communication really became much more viable and robust. This, along with intelligence and computing power being built into the field devices, led to automated data gathering and communication. So with this came more frequent data gathering and the ability to monitor lower cost and existing machines at a reasonable investment price point. So more leading indicators were also able to be captured to better detect failures in advance of occurrence. Moving into the 2020s, as we start the decade, we're seeing a lot more focus on analyzing this large amount of data with various tools such as rules and engineering-based models, machine learning, and artificial intelligence. So the goal here is to filter the data gathered so only the important information gets to personnel, and it comes with some severity and recommended contextual information. So this allows reliability teams to focus on critical and more complex issues. Additionally, there's a drive towards integrating condition monitoring systems with other systems that are already in place to derive greater value. Before we talk about condition monitoring and its ability to enable remote operations and efficiency, I'd just like to mention that we're going to be asking a couple of poll questions of you, the audience, throughout the presentation. So you should be seeing a couple of questions pop up, and as you respond, we'll share the results as we go forward. So at this time, when we're all being asked to do more things with constrained resources and a lot of our personnel working remotely, modern condition monitoring systems can have multiple benefits that help enable this for your facility and improve team efficiency. At the sensor level, it starts with deploying intelligent sensors that automatically collect data, have the ability to detect events right at the sensor, and send all that data to a centralized platform in the cloud. So the best intelligent sensors are easy to deploy and automatically learn the behavior of the specific machine they're installed on, and warn of abnormal conditions without the user having to manually tell the device what's considered unacceptable. So this means you can have much more frequent data gathering happening than manual methods, and have the sensor adjust the type and period of data gathering based on the actual machine condition, without your team having to spend a large amount of time setting up these devices. You don't have to rely on a person physically going to the machine every time you want data, which, by the way, most of the time ends up being to collect data when things are running fine. But this smart, adaptable data gathering happens right through the sensor. Good sensors also have a robust communication method to get that data into the cloud, where now you can take advantage of the available processing power to perform automated analytics. So this initial analysis can determine the level of severity of events and recommend actions. Additionally, cloud systems offer the ability to quickly generate summary reports of machine health within your plant. So this flexibility means that systems can provide summarized, relevant information in easy-to-consume formats, with the option for team members to get detailed data when they need it. So with this information, your team can now easily prioritize issues and spend their time on the most critical items, rather than spending large amounts of time gathering and sifting through data just to identify trouble spots. Effective condition monitoring systems offer a variety of communication methods to personnel, with instantaneous alerts on truly critical events, as well as periodic summarized reports on less critical items to be able to gauge your facility's overall machine health. These systems enable relevant data to be sent to relevant personnel at the appropriate time, rather than requiring users to go hunt for it. Of course, the detailed machine data, both historical and current, should always be stored within that condition monitoring platform for easy on-demand access. This can be combined with machine maintenance records on the same platform to provide a more holistic picture when someone needs to do a detailed analysis. The other advantage this offers is it allows users to easily and securely share data on machines across their organization, and pull in subject matter experts and share best practices. Lastly, superior condition monitoring systems also enable integrations to other systems already in your facility. So an example would be the ability to connect your condition monitoring data and observations to your CMMS or maintenance system, So severe events can trigger the creation of a work order to review or overhaul a machine. This integration, along with accurate early warning from a trusted condition monitoring system, gives you time to properly plan maintenance and repair activities using already established procedures without someone having to be physically present in the plant for every single step. With our experience on a variety of condition monitoring systems across different industries, we've seen the whole range of systems, from those that underperform as well as those that generate some great returns. So at this point, we'd like to share with you some of the important areas you should look for when evaluating and implementing a condition monitoring system. These are things that will allow you to easily get the system up and running without spending a large amount of time or money, have it be reliable, trustworthy once it's running, and integrate the system easily into your existing workflows and processes. So to break this down into a few key areas, I'm going to hand it back over to Naveed.
Thanks, Akshay. So to Akshay's point, there's different ways to monitor your equipment out in the field. There's different types of sensors and different types of connectivity. So what we're going to do right now is kind of break them down into sensors, connectivity, and data management, and kind of help you out and give you some of the key factors that needs to be thought about in terms of picking the right tool for your overall field or your overall process of managing different equipment. So the biggest thing, let's start off with the first thing that would be the entry to the industrial Internet of Things space, or for your monitoring processes, is the sensors. So in the beginning part of the sensor is you got to make sure you have the right tool for the job. So if you got to make sure that the sensor that you pick can fit all of your environmental safety ratings. It can fit in terms of what you're trying to measure, if the running speed and if the overall equipment, when it comes to what you're trying to monitor, what kind of fault you're trying to monitor, they can fit all those faults in its frequency bandwidth of selection. And also the biggest thing that when you're looking at different sensors is that you want to make sure that the measurement quality and accuracy is over 90%. So a lot of things out in the field is that you can get a lot of information of how the sensor is doing, but not what actually is the percent error of the output result. So when you're looking at evaluating the sensor that you want to use, you want to make sure that at least from an overall accuracy standpoint, from what you're trying to measure, it at least meets a 90% of accuracy throughout the spectrum. You want to make sure that it has an onboard memory in terms of historical data. So it's good to have an idea what is happening right at this very moment, but to get a full idea of overall system and how it kind of behaved in terms of before it went into an alarm state or after, it'll be great to have a trending analysis tool that gives vital information to, first of all, evaluate what went wrong, if it was a process subset or if it was actual mechanical fault, but also in the future to predict if a similar equipment or a similar fault is seen. So those kind of tools will definitely help you if you have something that can be able to trend that measurement, whether it's vibration, pressure, temperature, whatever it is. One huge thing about sensors when you're picking a sensor for your particular process is the ease of use and ease of installation. You can have the best sensor out in the market, the best accurate sensor, but if it's not easy to use, especially for people who are using it on a daily basis, and you want them to use it on a daily basis, right? You want to make sure that this is regularly used and regularly checked upon and regularly interrogated so that you get the best benefit of your sensors. You want to make sure that the person actually using it can use it without having to go through a lot of red tape or multiple steps. And installation is very key, especially for the current environment that we're in, where the resources are limited, where we don't have a lot of time to go out there and check in this field. If we can make the installation as minimal as possible without doing any conduits and stuff like that, that would be the best case scenario. So that's pretty much some of the biggest things that you want to look into when you're looking into sensors. The next thing is how you connect to that sensor. How do you talk to the sensor, get feedback from that sensor? So the biggest thing is that you would want to, first of all, make sure you can communicate that to that particular sensor locally and remotely. So when I mean by locally and remotely, I mean It'll be great for me to sit in my desktop away from the field and look at everything and see how it's behaving, and then communicate to that particular sensor and change the thresholds if I want to. But if I'm out in the field and if I see, take an example for this eyelet sensor that you see on the slide, if it starts blinking red, I would love to know what it is and communicate to it right there and then, instead of going back to my desktop and finding what the issue is. So if I can communicate to a particular sensor right where I'm at, whether that's on my desktop or whether right in the field, that is huge when it comes to connectivity. Obviously, download speed. We don't want to sit there and take multiple minutes to just download one single point. If I can download everything as quick as possible, especially with the limitations and taking into consideration the limitations of connectivity, if I can optimize that, that would be extremely vital for my general day-to-day operations, and obviously when you add up in terms of just interrogating it on a daily basis. And you would want to communicate more with the sensor if the download speeds are optimized. Obviously, one big thing is the security piece. So you want to make sure that if you're connecting to it, to a sensor, there's no way some kind of malicious person or a network comes into your access point. So if you can isolate that sensor and the connectivity to its own intranet, or basically its own communication protocol, and that has no access point to your network for your particular company, that is the easiest way to get it into the company, first of all, and it'll be definitely make your IT professionals happy as well. But the last point is scalability. So that's something that we need to spend a little bit of time on, pretty much, because if you have something that's working for you at a local level, like just from you communicating to the equipment, we want to make sure that you can scale it to a managerial level, and also if you want to now go into a corporate level. So that scalability should be there, because if you spend so much time picking up a good solution for your reliability group, you want to make sure that it's scalable. If this process or this type of measurement devices is chosen, that you want to use it for more of a company-wide or for other parts of your business as well. So those are two things that you want to really look into. But now the next step is, all right, I have all this data coming in. How do I make sense of that data? Where do I look at the data, and what do I actually do with that data? So that's where the data management piece comes into play. So at the end of the day, the data management is just a location where you can grab all this data, whether you grab it locally or remotely, but you grab all this data and you want to view it and manipulate it. So when you're looking at it, picking the right data management platform, the biggest thing is, what I've heard from a lot of customers, is that they would like to view it, but also they would like to transfer that data and then manipulate that data according to what they want to do it. So if you have an option for a platform that can provide those kind of features, that is huge. Obviously, if you have the scalability like we talked about for connectivity, even for data management, you don't want to have a limitation of X amount of sensors or X amount of users. You want to make sure that this will go as much as you want it to go in terms of your individual size of your plan, the size of your industry, but at the same time, you don't have that. You don't have to have that limitation to always hang over your head. Also, the biggest thing is to make sure everything's on one page. So a lot of people have out in the field have said that I don't want to use 3 different softwares to get 3 different measurements. I want to have one software that I can see all of it in one single platform, and have everybody use the same platform so that everybody's on the same page, and there's no figuring out what is one person seeing over the other. So that is huge. So that is something that you definitely want to keep in mind when picking up a good data management software. Able to send notifications. So it's great to have all this data, but if I don't get notifications, if something went into something, like I said, bumped the night in a third shift or a second shift, you want to get that notification automatically and very promptly. So that is something that you definitely want to look into when you look picking up a data management software. And also, if nothing's going wrong, at least to have some kind of an idea how it's going in terms of how the plant is behaving from a monthly basis. So if I can get an automated report that tells me that your equipment in this location, all of it is behaving fine. If it's not behaving fine, then it gives me a quick synopsis of, all right, this is what you need to look into. This is what you need to have your team take a look at. So actionable data, that's the biggest thing, right? The analytics piece. So data management is good, but all that data, if I have to send that data to someone else to make sense of it, that really is not the most efficient platform either. So getting the data is the first step. Now making sense of the data and giving you actionable results is the next step. So if you have a data management tool that has analytics built in, that would help you tell you what the issue is by just you grabbing the data and running it against rules-based diagnostic engine, and then gives you an idea of what the result is, and also will help you maybe give you an idea where you want to go for your path forward. So those are different things you definitely want to keep in mind, and definitely want to understand the nuances of different data management softwares. But the key factors that I mentioned is something that you definitely want to keep in mind before you get into picking a data management software, and that goes the same thing with connectivity and also the sensor part. Now, going to the next topic is we talked about downtime, we talked about costs, we talked about how the management of the data and how condition monitoring has evolved through the past 3 decades, and how we are planning on getting more in the future with analytics, and how we're going to, how it's much more easy to get into this industrial Internet of Things realm, much more than it was in the past. So I want to just give you some real-life case studies to show you how people have used it, and how it's much easier now to get into this and prevent some downtime. So this is an example of a boiler-free fan experience. Doing the normal preventive maintenance routes, this particular company saw that they had elevated high vibration, and because of this elevated high vibration, doing that route, they decided to put some eyelets with condition monitoring device on this particular fan, and they put it on 2 different locations, one on the inboard and one on the outboard, and then they were able to find out just by installing them, and it took them about 15 to 20 minutes to install them, and once they installed it, they were able to start monitoring the vibration, and within, I would say within a day or 2, they were able to start seeing how the high vibration, trend high vibration, and were able to send out teams to figure out what was wrong with it, and they found out that this was due to an issue with the inboard and outboard bearing sleeves, and was able to execute a repair, and within less than an hour was able to save an unplanned downtime. But the biggest thing is also in reduced infant mortality, right? So once they were able to set up, they repaired it, they started up again, they found out that right in startup, after they fixed it, they still saw high vibration. So that's where the whole the historical data in the sensors comes into play. If we didn't have that trending analysis tool, or that the tool to tell us what happened and how it's happening and keep that record, we wouldn't be able to find out that after the repair, it still had some high vibration. So when they went back to that equipment, they found out they had the thrust pads were damaged. And that was done because the iAlert, in this case, the iAlert system was able to notify their particular reliability team by showing that while on startup, they were showing some extra unintended vibration, and it was caused by the thrust pads. So this was just a quick example of how it was easy to install this condition monitoring device, how it was within very few amount of time, they were able to fix the issue, and then able to trend the repair, and was able to find another issue because of the trending analysis, and also using a data management tool to send notifications to the reliability team saying that, hey, your repair was done, but we still are seeing some kind of high elevated vibration. So that's just a quick synopsis of how condition monitoring tools should be used, and how how the right decision of picking the right one definitely helped this particular reliability team. So now, going forward, I would like to introduce our guest speaker, Troy Broussard, and I'll let Troy Broussard introduce himself, and then I would like to just have a quick discussion with him on his experience with downtime and how condition monitoring has helped the field.
Thank you, Naveen. Yes, wanted to just kind of cover, you can see, I've been involved in condition monitoring with the with a strong background in vibration since 1988. I worked with two of the largest condition monitoring companies out there today, and worked in a refinery as an end user for 4 years, a little over 4 years at one of the larger refineries in Texas, actually in the United States. So one one thing that we found over the years, we've run routes, we do large machinery with multi-channel analysis and data collection. The early slide brought back some memories when we used to tape data, use tape recorders, reel to reel, and then go back into our office and play them back into a big real-time analyzer because we didn't have the portability we have today. We've been playing around, if you will, with the iAlert for about 4 years now, and it's over time with the gateway and all has really increased the ability for us to get data. And we got a client that we do their process. They lost their bag house, so they get a lot of carryover from melting down recycled metal, and it seems to build up on the fan quite frequently. They've had some failures in the past, so in December we decided, hey, let's introduce them to the iAlert. Let's see if this will work for them because they've been running to failure. And what we did was we 3 iAlerts, 2 on the bearing motor on the blower bearing and 1 on the motor, and installed them. And within less than 2 months, the vibration started trending up. The client, it was their only machine, so their client with a smart device using their Android phone was able to go out and look at the data themselves. They didn't understand what we would call the squiggly lines, but they understood the trends. They said, hey, this is trending up. Let me send you the data. And they screenshotted some of the data the first time. And so, well, let us come out and check it. So we did. And what we found was it needed to be balanced again. So we balanced it. It was a 2-hour start to finish. Finished up the balancing. They were back up and running within 2 hours. And I asked the CFO if he could share some data with us. So $1,000 investment of iAlerts, and they showed about a $17,000 cost savings because normally they would have run this to failure if they didn't have a way of monitoring it. Within a couple of months after that, we just went back out again in April. It was trending up. The screenshots were a little tougher to see, so we asked them through the app to send us over the CSV file extension. So we were able to import that into an Excel spreadsheet, recreate the FFT so they were a little clearer for us. And sure enough, we wound up going back out again and doing another balance. Now they're supposed to be getting a bag house in the June timeframe, and they're kind of limping this thing along to that point. But that would have been 2 failures they would have had without the iAlerts present. So we've become a strong proponent of the iAlert in multiple situations. And I try to tell everyone when we talk about it, know what it is and know what it isn't. So when you start seeing those trends, we look at those portable handheld data collectors and some of the real-time analyzers and things that we use in the field. This is going to be the monitoring component of this. It's going to show you when things start trending, but there still may be some times where you call an analyst out who's going to have to go out there, troubleshoot the whole solution, come up with a final root cause on this thing so that you can go in then and fix the problem once and for all. In our company, we had a gentleman from Croatia, and for those of you who came to America and it's not your first language, he used to always say it's called FFT, and that's not fast Fourier transform. It's fix it the first time. So understanding the failure and watching how that failure pattern progresses so that you can get to the root cause of the failure and not fix the symptoms, but fix the cause. And this is where running route data every 30 days can give you an idea of what's happening. When you put this in, augment your route data collection, then it's showing you a much bigger picture that you can see what's happening in between the 30-day collection. So we're promoting this with our client base because it does give you a broader look at what's going on. So you can see the different operators and how they operate the plant and what happens to the machinery based on level changes and process changes that you wouldn't get when you're running portable route data collection. So the downtime aspect of it that the whole trigger behind this is to really get key information so you are better informed as to what's driving your downtime, what's driving your faults, and try to fix those faults. And many times you can find it's human error, and not just mechanical problems that just occur. So being able to trend these machines over time and understand where those faults are coming from is key to increasing availability and reliability of your equipment.
That's right. Thank you so much. Thank you so much for that. I'm definitely going to use the fix it first time for sure. No, and see, that's something that you definitely, as an expert out there in the field, would definitely know. I just wanted you to maybe, first of all, thanks for the example of using the iAlert, how that definitely helped you save and your customer base save that much amount of downtime. But in your example or in your experience, what's the most amount of common downtime that you've seen out in the field? And also, how does, I mean, obviously we talked about condition monitoring helping that, but how is it now just adding another tool in your toolbox to help you with the non-common downtimes out there in the field?
Yeah, the big challenge in most cases when you start looking at what drives downtime, if you really look in process equipment, especially in the petrochem industry, where we're right in the middle of it, is many times the pump comes down because of a seal failure. And they're tracking, if they track the machine failure rates, many times they say, well, we don't really have a bearing problem. Well, what occurs in many cases, either operations drives the pump into cavitation over days and weeks that you don't really see if you're doing route data collection all the time, or you start having an early stage bearing failure that the technician may not have his data collection set up to catch the early stages of that. The chatter starts happening, your seal starts to chatter and starts the failure part. So anytime you pull that pump out, they're going to put new bearings in anyway. So the bearings may be at a very early stage of fault, which has driven your seal to start chattering and fail. But they want to point to the seal being the failure point and not the bearings. So what we see most, to answer your question, Naveen, in unscheduled outages here, especially with the hydrocarbon aspect of it, is seals take out most of the customer's machinery more than any other problem. But that still drives the point of what's causing the seal to fail. Yep. If the seal's properly designed, why is the seal failing? What is that driving force that makes that seal fail? And if you're not really looking at the big picture of what's going on, many times you'll get that. And many customers have gone into these seal programs because they feel like they're getting a good price on seals rather than addressing the root cause of the seal failure. Instead, we'll just get a cheaper seal. We'll partner with one company and we'll get better pricing on our seals. That doesn't address the availability aspect of it, of an asset though.
Yep. And that's where I would think the whole trending tool to see how that process has changed or has upsetted to get to that point of the seal failure, right? I mean, the trending is, do you want to talk a little bit about the trending, how that is definitely a big benefit in terms of condition monitoring?
Yeah, as I tell a lot of our clients, many people can look at a trend, when things are going up or going down. The trends are fairly easy to everyone can understand a trend. The real crux comes down to when you're wanting to do the analysis piece. It's like going to your physician, your primary care physician. They look at you as an overall condition. When there's a specific problem, they send you to the specialists. So if you think of iAlert, what we've kind of come up with is the iAlert is really the iWatch of condition monitoring. It monitors your heartbeat. It looks at, it can look at arrhythmia and other things just on that thing on your wrist. So it's there that gives you that first indication of what's going on. So it's a good tool to give you that, hey, this is what's going on. Here's how things are trending. And then at some point we say, okay, we need a specialist to help us out. And that's where this really comes into. The trending part gives you the feel that your equipment is running nice. We installed about 50 or 60 at one of our client sites, very small facility. They put one on every one of their pumps and motors. We were doing a monthly route data collection. About a year into it, once they got everything populated, they basically said, "We've got it from here. We'll call you when we need you." And they've basically used the iAlert as their key condition monitoring tool. They don't use an outside company unless there's a problem, they need someone to come in. So that's a success. And then one other I was going to mention, I haven't written this up yet, but in talking to our most recent customer, he's using iAlerts right now. We're about to install a gateway next week, and he installed an iAlert. It was in the evening time. He was not at work, and one of the coworkers saw the iAlert flashing red, and he called him up and said, "Hey, this thing's flashing red. Is that something of y'all's?" And he was able to go out, find that they had broken a bolt on a fan, and the whole frame was shaking. And we've not written that one up, but we're going to be working on that one. So that kind of really drove them to start looking at how to make this transition to online monitoring, even though he does monthly routes, and then also integrate that with their OSI Pi, so their operators can get the trending as well. So they get to see, everybody gets to see it.
No, Troy, I really appreciate you kind of giving your real world experience. Obviously, you've been in the field for over 30 years and more than that, but just really appreciate you giving your time. And no, thank you so much for telling us that those instances where a condition monitoring tool like iAlert has helped you out in the field and helped your clientele as well. So thanks, Troy. So just a few points on what Troy mentioned is how the data management, just to be notified when an issue is happening, a sensor that is accurate enough to trust the data that you're seeing out of it, easy to use, easy to install, and also to communicate to it, whether it's locally or remotely, or whether to have it, just to have this option of keeping that within a local realm or a remote sense or a corporate sense, having that able to be scalable. All that is very key factors, and it's good to hear that Troy is successful enough with the iAlert system, but those are the main things you want to look into when picking up a good overall solution for your reliability needs. So one thing before I let you guys go, we're going to take some questions and answer for the next section of the webinar, but I just wanted to just leave one quick thing. If you guys ever want to get more information about, obviously we represent the iAlert system and all the different components that comes with it, like the gateway, the different sensors like pressure and vibration, also the mobile app and the data management firm. We definitely will be able to help you if you have any questions regarding anything that we've talked about in this webinar, or if you guys want to have a quick schedule for a demo or any kind of information regarding what we talked about and also our product line, please reach out to myself, all the speakers that you heard today, and also we have an Amazon webpage. You can just go to our store and you can definitely get one of those iAlerts that we talked about, but really appreciate you taking time to hear our webinar. But I'll now transition over to David Rail, and he'll be taking some of your questions.
Thank you, Naveen. Appreciate that. Jared, do we have any questions coming in?
Yeah, we have a few questions coming in. Just to encourage everyone, there is a Q&A section on the WebEx there. We already see some people participating through it. If you want to share some questions on there, we'll try to get to as many as we can for the rest of the time that we have. Just want to share the first one that came in, kind of summarizing a little bit. Question is the system intended for existing installations or new plants? Is there a cost difference between these applications?
All right, that's an excellent question. I think what the crux of this question is getting at is what is the difference between a wired system and a wireless system, I think. Because putting in the infrastructure into a new plant or an existing plant for a wired system is extremely expensive, putting in all that infrastructure. But however, the cost between an existing plant and a greenfield plant don't change tremendously. If you look at the cost of putting in that infrastructure over the cost and the life of the plant, it's not a tremendous difference. But the larger issue here is technology obsolescence, which clearly favors a wireless system. For example, if you were to put in a wired system, and in certain cases a wired system is apropos in a plant for critical equipment, but suppose you put in a wired system and in 10 years, 8 or 10 years, that system now becomes obsolete. You now have put in a lot of infrastructure that you cannot use for another system downstream. So I would say, you know, based on that, the world is going to wireless systems. However, there are instances where a wired system is still appropriate, such as, you know, a critical plant asset like a turbine that needs to have a Bentley Nevada system or something like that. All right.
Thanks, Dave. There's a question on classifications. How do we handle Div 1 or Div 2 hazardous areas in refineries?
Well, specifically with the iAlert, the iAlert is Class 1 Div 1 rated. We have a gateway that is Class 1 Div 2 rated. And the gateway in a refinery or another installation where that, you know, the gateway has to be placed outside of the restricted area, the hazardous area. Typical range on a gateway to an iAlert is 250 feet line of sight. So that's usually feasible to do that. All right.
Just a follow-up question. You mentioned the gateway. Someone had a question of how many of the sensors can actually one gateway support?
We've tested them in our lab, and Naveen, I think you can support me on this. We've tested up to about 264 on a single gateway. That would be, you know, it doesn't seem to slow things down at all. That would be an unusual case where you have that many iAlerts that close. A more typical installation would be, you know, 50 to 100, say on a paper machine or something.
That is correct. So in the end of the day, there's no ceiling with the number of users. It just comes down to your range of your Bluetooth, and the gateway range is, since it's powered externally and the bigger antenna, it has a much more range than your cell phone does. But in an industrial environment where we would see anywhere between 150 to 200 feet of Bluetooth range, we're taking regard to all the obstacles, but yeah.
And then in regards to the number of iAlerts there was a question on, do you have to put an iAlert on the pump and the motor, one for each?
It is better to do that. If you put one on the drive end of the motor and the driven end of the pump, that is probably the optimal setup. That's where most of the failures, you know, bearing issues and things will occur. Typically on the drive piece of equipment, the driven piece of equipment is where you will see the issues first. However, the drive end of the motor is also a good place to put an iAlert.
Can you talk about the calibration of the iAlert, how that kind of works with each unit?
Yeah, sure can. The iAlert being a semiconductor device, the sensor inside the iAlert is what we call a MEMS sensor. It stands for Micro Electrical Machine System. So those sensors do not require calibration. And that's, you know, not true of a crystal type sensor. A crystal sensor requires a calibration. It also changes dramatically over temperature, and it also will change dramatically if the sensor is jarred or shocked in some way that changes damages the crystal of the sensor. The iAlert being a semiconductor is essentially immune to those kind of changes. So there is no calibration. It's, you know, analogous to the clock in your computer. No one calibrates the clock in their computer because it's a microchip and it doesn't need calibration. So the semiconductor aspect of the iAlert is what accounts for that lack of calibration, and also the lack of drift over things like temperature, lack of significant drift.
Okay, we have a couple of questions that are coming in a couple different ways. I'm trying to sum them up. So one is on the installation of it. You know, what are ways to, other than bolting and screwing it in, what are ways to do that? And then related to that, obviously, is the battery life. So if you're going to be, you know, replacing it, knowing the batteries don't last forever, you know, what would you say is a typical battery life of one?
Well, I'll answer the first part of that question first. The ways to install it, the iAlert can be screwed directly onto a pump. If it's a Gould pump, it has something called there's a I-frame design that allows you to put the iAlert directly in the most advantageous spot on the pump. If it's a competitor's product, and that doesn't necessarily mean a pump, it can be a blower, a fan, a compressor, et cetera, you can epoxy the iAlert onto the equipment. And the way to do that is we sell bases that go under the iAlert, and these bases are inexpensive, so you would screw the iAlert to the base and then epoxy the base onto the equipment. And we recommend using an epoxy that has, since the iAlert is measuring temperature, we recommend using an epoxy that has, you know, metal or aluminum chips inside to give good thermal conductivity up to the iAlert. You can also use that mounting base. It has dimples on it, which allow you to get on a curved surface as well. So you can also do a through bolt through the iAlert, through the mounting plate, onto a curved surface like a motor or some other centrifugal piece of equipment that you might have.
Hey, David, can I interject here? This is Troy. Just also be very aware that if you're using some of the sensor magnets out there, to try to use the iAlert with some of the industrial magnets for the accelerometers, it will impact the device because of magnets on the bottom of the sensor tend to turn it off and because of the way that things are designed. So if you want to talk just briefly about that, you don't want to put this thing on one of the typical accelerometer magnets.
Yeah, correct. I mean, we have a special magnet that we sell that goes with the device and works very well with the device. What Troy's referring to is we have a Hall effect sensor that essentially is used to shut the iAlert off and put it in various states of sleep mode that exists in the device. So if you get a magnet too close to it, a strong enough magnet, and we've reduced the sensitivity of that Hall effect switch so that now it takes a much stronger magnet to shut it down. But you can, if you get a magnet too close to it, you can in fact shut the device down. So, and let me go to your other question. You had a question on the lifetime of the battery. Typically, 3-year battery life is our expectation. That's what we see in the lab. That's sort of the standard bell curve of failure that we see in the laboratory is the midpoint is about 3-year battery life. On hot service, and when I say hot service, I mean above 170 degrees F, you will see that battery life go down. And that's really, it's a physics issue. It's the batteries are affected by that, not just ours, any battery is affected by temperature. So you will see that temperature drop. If, to give you an example, if it's on a piece of equipment where the surface temperature is 170 degrees, you would expect a life of about 1.6 years on it. So you would essentially cut the life in half due to the higher temperature.
Thanks, Dave. There was a question coming in about the RPMs. Are we limited to that? Does it work down to 900 RPMs or less?
No, the bottom end of the iAlert it will work on 900 RPM. The bottom end is 300 RPM. We have filters in the iAlert that to keep noise out of the system. We have filters that cut off the bottom part of the spectrum, such as that. However, do we have customers that are using it on slower speed equipment like mixers, conveyors, and things such as that? We do. However, you will not have the benefit of seeing the primary peak in the spectrum. So you will see the subsequent peaks in the spectrum, but you will miss the primary. And typically the primary is where most of the information is. So it's not necessarily recommended, but we do have customers that are using it that way.
Yeah, just to add to that point is that a lot of customers that use it, that have a lower running equipment, they look at relative change. So since we show the overall energy throughout our spectrum, when you have something going wrong, the overall spectrum goes up because of excited vibration or temperature and stuff like that. So that's what a lot of those customers use it for, just to see relative change, which is a good indicator of if something's going wrong or if something is behaving normally.
Yeah, good point, Naveen. And Troy alluded to that when he spoke earlier regarding looking at trends. A lot of this, the mystery of this science is you're looking for changes, and then you call in the specialist. So that's absolutely spot on.
Okay, I know we're getting close to the end, so I want to grab a couple of questions, make sure we get them in there. One is on the app. Is there a specific app they need to download to work with this?
Yep, you can go to either the Apple Store or the Google Store, and you can download our app. I find you can search for iAlert 2, or you can search under Google's, and you will find it. It's free. The app is freely downloadable. Works with the device standalone. There's nothing else you need to have to start condition monitoring right away. And we encourage as many people to download it as need be in your plant. So anybody can become a data taker.
So with the condition monitoring, does it align with any tools to be part of a scheduled maintenance program? Can it be connected?
We have the ability to get our data into many disparate systems. Once the data goes in the cloud, as our data feeds up to the cloud, we can get that into any kind of a DCS system, any kind of a data lake or repository you may have, or even into some operations type systems, historians, things like Emerson Pi and whatnot.
Yeah, and also to transfer that data, just to get the raw data out. And then at the end of the day, when you collect that data and when you store that data in the cloud, that data is yours. So if you want that data to be formatted in a certain way, obviously we have certain formats that we send it out automatically, but that's one thing that is good with us. We're very flexible to work with your needs, and if you have something that you need to transfer in a certain protocol, that's something that we'll definitely be open to have a conversation with. But that's the biggest thing with us. We are definitely flexible with transferring the data in and out.
There was a question on cost of infrastructure, being that it's obviously always a consideration. What's the typical range of the gateways, or how many would be required in a typical plant?
We have some operations where we have as few as 2 and as many as 3. It just depends on, basically it depends on the range to the eye alerts. So, and how spread out those eye alerts are over your plant. Keep in mind, as Naveen mentioned earlier, that a gateway has significantly greater range than using a handheld device, either a phone or a tablet. And the reason for that is the gateway has better electronics, higher gain antennas inside. So a gateway typically has much greater reach than a phone or a tablet. So we find that, you know, I mean, for instance, we've done a fairly large paper plant and we've installed 3 gateways and we've covered the entirety of the plant. As an example.
And yeah, and to give another example, we did a large chemical plant, and they did 4 gateways with covered most. I mean, they're spread out by a huge distance, but at the end of the day, they focused on pockets of assets, and they were able to get about 250 assets covered by about 4 to 5 gateways, and that was what they wanted to get at. They wanted to use the least amount of hardware to gain the most amount from their overall system. So just another example to Dave's point.
Okay, I think we have time for 2 more questions. One of them is based on one of our poll questions about planning or already planning to already have a condition monitoring program. How would someone get started with that, knowing that some people probably on the call are looking into that? What would be the best way to get started?
As a a newly developing condition monitoring program, you've got a blank sheet of paper and you're trying to set up a condition monitoring program. I would say the first thing you would do is you'd want to look at all the assets you have in your plant. Look at kind of categorize those as to which assets are critical. By critical I mean vital to the operation of the plant. And then I would create tiers of these. The second area might be the pieces of equipment that are that you have problems with from time to time, but are not critical to the operation. So-called bad actors, machines that don't have, necessarily have a redundant backup and can cause issues. So once you have the machines, all the assets in your plant kind of categorized, then you would kind of do attack the lowest hanging fruit first and start putting monitoring on those pieces of equipment that are giving you the most trouble and are most critical to the operation of the plant. I would say lastly, you would want to look at all the other, the plant equipment, so-called balance of plant type equipment.
And just to add to that, if you have any questions on how to start, obviously just reach out to us. Since we have done this, this is what we do out in the field, and obviously to Troy's point, we have other good resources that we can definitely rely on. So if you guys have any questions on how to start, or just also not even start, just to improve your data conditioning monitoring system that you already have, just give us a call, send us a quick email, and we can definitely help you out with that.
Okay, I see we're at the bottom of the hour, Naveen, if you just want to kind of wrap it up.
Yeah, no, again, for everyone that joined, everyone that participated in this webinar, really appreciate you guys taking the time to do this. We're planning on doing more of this to get more awareness out about, obviously, unplanned downtime, but also how to reduce the impact of it and how to make sure that you cover all equipment, not just the critical ones, because every single asset counts. And if you guys need any more information on our product line, which is the Isler product line, just please send us an email, go to our website, definitely reach out to us and we can help you guys out. Also, just generally, anything that you guys need in terms of condition monitoring, just definitely reach us. And again, thank you so much, and you guys all have a great day.